Chapter 21, Section 2, Interactive Reader, pages 315 through 320. 19 points. Weather. Fronts. Key ideas. As you read this section, keep these questions in mind. What weather patterns do warm and cold fronts bring? How does a mid-latitude cyclone form? How do hurricanes, thunderstorms, and tornadoes form? Page 315. What is a front? Which type of cold front may form a squall line? What is a front? Air masses that have different densities. Highlight. Cool air masses are denser than warm air masses. Continue highlighting. These density differences keep the air masses separate. Continue highlighting. As a result, a boundary forms between air masses. Keep highlighting. This boundary is a front. A typical front is several hundred kilometers long. Some fronts may be several thousand kilometers long. Highlight. In the middle latitudes, changes in weather happen along fronts. The middle latitudes are the regions between the tropical and polar regions. Highlight. Tropical regions do not have fronts because tropical air masses do not have large differences in temperature. Number 1. What is a front? Answer. The boundary between different air masses. A boundary between different air masses. What are the types of fronts? Highlight. One air mass must collide with another air mass to form a front. Continue highlighting. The type of front that forms depends on how the air masses move. Cold fronts. Highlight. A cold front forms when a cold air mass pushes under a warm air mass. Continue highlighting. The moving cold air lifts the warm air. Continue highlighting. If the warm air is moist, clouds will form. Continue highlighting. The front moves in the direction the cold air mass was moving. Cold fronts can move at different speeds. Highlight. Fast-moving cold fronts lift warm air more quickly than slow-moving cold fronts do. Continue highlighting. The speed of a cold front affects the weather conditions along the front as shown below. Types of cold fronts. Highlight. Fast, resulting weather conditions, large clouds, short violent storms, chance of long line of heavy thunderstorms called highlight a squall line. Slow, weaker storms, light precipitation. Question 2. Which type of cold front may form a squall line? Answer. Fast. Fast. Page 316. What types of weather commonly forms along cold fronts? How is the slope of a warm front different from the slope of a cold front? What happens to warm air as an occluded front forms? Circle the cloud type under the cold front. On the right-hand side, large cumulus and highlight cumulonimbus clouds usually form along fast-moving cold fronts. Question 3. What type of weather commonly forms along cold fronts? Answer. Stormy weather. Stormy weather. Warm fronts. Highlight. A warm front forms when warm air mass pushes a cold air mass. Continue highlighting. The less dense warm air rises over the cooler air. Continue highlighting. The front moves in the direction of the warm air mass was moving. Continue highlighting. A warm front has a gentle slope. Continue highlighting. As a result, clouds may stretch ahead of the surface location or base of the front. Continue highlighting. A warm front causes precipitation over a large area. It sometimes causes violent weather. Next to the diagram, clouds may extend ahead of the base of a warm front. Question 4. How is the slope of a warm front different from the slope of a cold front? Warm front has a gentle slope. A warm front has a gentle slope. And a cold front has a steep slope. And a cold front has a steep slope. Again, a warm front has a gentle slope and a cold front has a steep slope. Stationary and occluded fronts. Highlight. A stationary front forms when air masses move slowly or not at all. Continue highlighting. A stationary front causes weather similar to the weather of a warm front. Continue highlighting. An occluded front forms when fast-moving cold front lifts a warm air mass completely off the ground. On the left of the diagram, you have a cold air mass. In the middle of the diagram, you have a warm air mass. On the right of the diagram, you have a cold air mass. That is an occluded front. Next to the diagram, an occluded front forms when a cold air mass lifts a warm air mass off the ground. Question 5. What happens to warm air as an occluded front forms? Answer. It gets completely lifted off the ground. Again, it gets completely lifted off the ground. Page 317. Would a wave form along the equator? Why or why not? Name 3 types of fronts shown in this mid-latitude cyclone. How do cyclones form? A dome of cold air covers each of Earth's polar regions. Highlight. This cold air meets the tropical air mass of the middle latitudes at the polar front. Highlight. Waves often form along the polar front, as shown below. Continue highlighting. A wave is a bend that forms in a cold front or a stationary front. Continue highlighting. This wave is the beginning of a low-pressure storm center called a mid-latitude cyclone or wave cyclone. Continue highlighting. Mid-latitude cyclones are areas of low pressure that have rotating wind. Continue highlighting. The wind moves toward the rising air in the center. Continue highlighting. Mid-latitude cyclones strongly affect weather patterns in the middle latitudes. They usually last for several days. In North America, they usually travel east at about 45 kilometers per hour as they spin counterclockwise. The cyclones may lose energy as they pass over mountains. Question 6. Would a wave form along the equator? Why or why not? No, because waves form along the polar front. No, because waves form along the polar front. As we look at the image, top picture, highlight the word stationary front, first words, stationary front. Mid-latitude cyclones start to form along a stationary front. Winds blow in opposite directions along the front. In the second image, highlight the words warm front. A wave forms when a bulge of cold air forms and moves slightly ahead of the rest of the front. Third image, occluded front stage. Highlight the word occluded front. The fast-moving part of the front moves up until it reaches the warm front. An occluded front forms. Final picture, dissipating stage. Eventually, the system loses most of its energy. The cyclone breaks apart. Question 7. Name 3 types of fronts shown in this mid-latitude cyclone. Answer: stationary, warm, occluded. Again, stationary, warm, occluded. Page 318. How are anticyclones different from mid-latitude cyclones? What causes a thunderstorm to break apart? How do tornadoes form? Anticyclones. Fronts can also cause anticyclones. Highlight: the air in an anticyclone sinks and flows outward from a high pressure center. In the northern hemisphere, air flows clockwise around an anticyclone. Highlight: anticyclones bring dry weather. Continue highlighting. If an anticyclone stays in one place, it may cause air pollution problems and drought. Question number 8. How are anticyclones different from mid-latitude cyclones? In a cyclone, air rises and moves toward the center counterclockwise. Again, cyclone, air moves toward the center, air rises, moves toward the center, counterclockwise. In an anticyclone, air sinks, moves out from the center, and clockwise. Again, anticyclone, air sinks, moves out from the center, and clockwise. Again, the whole thing. Cyclone, air rises, moves toward the center, counterclockwise. Anticyclone, air sinks, moves out from the center, clockwise. Thunderstorms. Highlight: a thunderstorm is a heavy storm with rain, thunder, lightning, and strong winds. Thunderstorms develop in 3 stages as shown below. Highlight: cumulus. Highlight: warm, moist air rises. The water vapor in the air condenses to form cumulus clouds. Highlight: mature. Highlight: the water vapor continues to condense. Continue highlighting. The clouds rise and become dark cumulonimbus clouds. Continue highlighting. Heavy rain or hail may fall from the clouds. Downdrafts form as precipitation drags air downward. Highlight: dissipating. Highlight: strong downdrafts stop air from rising. The supply of water vapor decreases. The thunderstorm breaks apart. Question number 9. What causes a thunderstorm to break apart? Strong downdrafts stop air from rising. Strong downdrafts stop air from rising. Stopping the supply of water vapor. Stopping the supply of water vapor. Again, strong downdrafts stop air from rising, stopping the supply of water vapor. Highlight. Parts of a cloud can have different electrical charges. Continue highlighting. To make the charge equal, clouds may release electricity as lightning. Lightning can travel within a cloud or between a cloud and the ground. Highlight. The lightning heats the air and the air quickly expands. Continue highlighting. The expanding air produces the loud noise called thunder. Tornadoes. Highlight. A tornado is a spinning column of air that has very high winds. A tornado appears as a funnel-shaped cloud. Tornadoes last a short time, but they are very violent. Highlight. A tornado forms when a thunderstorm meets high-altitude horizontal winds. Continue highlighting. These winds spin the rising air in the thunderstorm. Part of the storm cloud may reach down in a narrow funnel shape. This funnel may or may not touch the ground. If the funnel does touch the ground, it generally moves in an irregular path. How do tornadoes form? Answer. A thunderstorm meets high-altitude horizontal winds. A thunderstorm meets high-altitude horizontal winds, which spin the rising air in the thunderstorm. Which spin the rising air in the thunderstorm. Again, a thunderstorm meets high-altitude horizontal winds, which spin the rising air in the thunderstorm. .319. Why are hurricanes more likely to hit states along the Gulf of Mexico than states in the Northeast? Why is a storm surge so dangerous? How wide is the hurricane in this picture? Hurricanes. Highlight. Tropical storms are intense storms that usually form in the tropics. Tropical storms are different from mid-latitude cyclones in many ways. Highlight. Tropical storms cover a smaller area. Continue highlighting. They do not have warm or cold fronts. Also, highlight, they are usually more violent than mid-latitude cyclones. Continue highlighting. A tropical storm with winds that spiral in toward a low pressure center is called a hurricane. Continue highlighting. A hurricane has wind speeds of 120 kilometers per hour or more. Continue highlighting. Hurricanes develop over warm tropical oceans. Continue highlighting. A hurricane starts when warm, moist air over the ocean quickly rises. The moisture condenses and releases a large amount of energy as latent heat. Highlight. Latent heat is heat energy that is absorbed or released during phase change. Highlight. A fully developed hurricane has thick bands of clouds. Continue highlighting. These clouds spin upward around the center of the eye of the storm. Continue highlighting. Winds increase near the eye. However, the eye itself is a region of calm sinking air. Continue highlighting. Hurricanes are the most destructive storms on Earth. Continue highlighting. The most dangerous part of a hurricane is a storm surge. A storm surge is, highlight, a rise in sea level with large waves. A storm surge, highlight, can flood low coastal areas and cause people to drown. Question 11. Why are hurricanes more likely to hit the states along the Gulf of Mexico than the states in the Northwest? Answer, because they develop over warm tropical oceans. Again, because they develop over warm tropical oceans. Question 12. Why is a storm surge so dangerous? It can flood low coastal areas and cause people to drown. It can flood low coastal areas and cause people to drown. Scientists classify hurricanes using many factors. These factors include highlight central pressure, highlight wind speed, and highlight storm surge. Scientists use these factors to rank hurricanes on the Saffir-Simpson scale, which has 5 categories. Highlight. Category 1 storms cause the least damage. Continue highlighting. Category 5 storms cause the worst damage. Under the diagram, the arrows in this picture represent the movement of moist air. Air moves the fastest near the center of the hurricane. Make a vertical line highlighting the 300 on the right-hand side where it reads heavy rains. Make a vertical line highlighting the 300 on the left-hand side. How wide is the hurricane in this picture? Answer, 600 kilometers. 600 kilometers. Page 320. How are the weather patterns produced by cold fronts and warm fronts similar? How are they different? How does a mid-latitude cyclone form? What are the 3 stages in the development of a thunderstorm? What causes thunder during thunderstorms? How are tornadoes and thunderstorms related? A meteorologist wants to study developing hurricanes. What areas of Earth should the meteorologist observe? Explain your answer. Question 1. In both, cold air moves under warm air. In both, cold air moves under warm air. Cold air is moving toward warm air in a cold front. Cold air is moving toward warm air in a cold front. Warm is moving toward cold in a warm front. Warm is moving toward cold in a warm front. Again, in both, cold air moves under warm air. Cold air is moving toward warm in a cold front. Warm air is moving toward cold in a warm front. Question 2. Answer can be found on page 317. A wave forms in a cold front or a stationary front. Again, a wave forms in a cold front or a stationary front. Question number 3. Answer can be found on page 318. Cumulus, mature, dissipating. Again, cumulus, mature, dissipating. Question number 4. Answer can be found on page 318. Lightning heating the air. Lightning heating the air. Question number 5. Answer can also be found on page 318. Tornadoes happen when thunderstorms meet. Tornadoes happen when thunderstorms meet high altitude horizontal winds. High altitude horizontal winds. Again, tornadoes happen when thunderstorms meet high altitude horizontal winds. Question 6. Answer can be found on page 319. Tropical oceans, because they develop over warm tropical oceans. Again, tropical oceans, because they develop over warm tropical oceans.